listener production.
Hey, Chris Spyrou with you. Welcome to The Briefing.
Within the 24 hours, the pain dropped 50%. The limp disappeared. Obviously, if you overdo it, you still feel it, but the pain doesn't linger overnight. There's no painkillers. It's been quite a remarkable process.
You just heard there from listener of The Briefing, Marie Casanidi, who I spoke to in part one of this story. Marie and her husband travelled to Thailand late last year to receive stem cell treatments on their hips. They say the results were almost instant and pretty life-changing. So what's the picture for stem cell treatment in Australia? Why did Marie and her husband have to travel overseas to get it? And is it time for a rethink? In part two of our special deep dive looking into stem cells, we speak with leading experts in the field here in Australia, including one who's received government funding for his clinical trials. Joining me first, though, is Professor Megan Munsie, Group Leader in Stem Cell Ethics and Policy at the Murdoch Children's Research Institute. Professor Megan, thank you so much for joining us on The Briefing. You've been involved in this field for more than a decade now. Why do you think we're seeing Australians travelling overseas to receive stem cell treatments?
Because I think we're all pretty curious about stem cells. We've all heard about it now for quite a long time. And we probably even know someone who's had a stem cell transplant. And here I'm thinking of people with leukemia or other blood disorders who've perhaps had their life saved through a bone marrow transplantation. So we use different types of stem cells in different ways in research. And then when we think about clinical applications, I'm often thinking about the kind of very specific targeted product that we're going to make from stem cells to treat someone with a particular condition. But what's happened over time is that there's a lot of excitement and I think extrapolation of that kind of promise of stem cells, so that there's this kind of view that stem cells are somehow like a miracle or a miraculous intervention that will help all. And we're not quite there yet.
Are we not there yet in Australia, or are we not there yet globally, in your opinion?
In my strong opinion, we're not there yet globally. We have a fantastic collaborative international network where researchers across the globe are working together and also in sort of separate projects, but we're sharing information. And so there's this terrific network. But these questions we're trying to solve are hard, and they will take time. And it's not progressing at the same rate for all conditions. So there's some examples of clinical trials where we've made the product from stem cells to put back into a person who is living with Parkinson's disease, for example. However, that product won't help someone who's got multiple sclerosis or a child who has a problem with sight. And that's where it gets kind of messy, particularly when now for over 20 years, we've been watching this expansion of companies and businesses, clinical practices, marketing that they already have a stem cell product. And that's where it gets really messy. So you've got this sort of clinical research program happening around the world. It's quite slow, it's cautious, it's frustrating for those who want to access. And then at the same time, you have people saying, hey, we're already there. Just bring your checkbook and we can help you.
We'll rewind a little bit. I think it's a good time now to set the basis of it all. What is a stem cell?
Fabulous question. So it's a really unique cell that has the ability to be able to grow into other cells and also make itself again, if that makes sense. So it can kind of keep producing cells on demand. And of course, we have stem cells in our body. That's what makes our blood cells. They live in the bone marrow and they make red blood cells, white blood cells and platelets, and they make themselves again. Because if they stopped making themselves, we would become anemic and have other challenges. We also have stem cells in other organs, like in the lining of our gut, in our skin, and that keeps us healthy and repairs when we're wounded and things like that. What we can also do, though, is isolate stem cells in the lab, and we can isolate them from human embryos. And you might remember back in the late 90s when this first happened, there was quite a lot of community discussion around whether that was appropriate and under what circumstances. the reason why we were so interested in the scientific community about using stem cells from embryos is that unlike the stem cells we find in our bodies that have a much more limited ability to make a particular cell, usually just the cells of that organ in which they're found, these embryonic stem cells, so stem cells isolated from an embryo in the laboratory, they can grow into anything if they're given the right signals. So from a scientific perspective, they're like kind of, plasticine. You can mold them and coax them to do what you want them to do. So it's like the embryonic stem cell, this really malleable kind of cellular material that we can coax to do what we want it to do. So for example, we can give it the right environment, the right chemical signals to form nerve cells. And that's really the foundation of that Parkinson's clinical trial I was mentioning a moment ago.
Yeah, I do want to talk about embryonic stem cell use. I guess the ethical debate around it all is early science suggested to extract those stem cells from embryos, it would effectively lead to their destruction. And that's just a few days after egg and sperm combined to do their thing. And then it was a few days after that embryo stem cells are extracted, and that leads to their destruction for that scientific discovery and for research to take place. Is that still where we're at when it comes to embryonic stem cells internationally and in Australia?
Yes, certainly. So in Australia, we've had law since 2002 that governs the use of human embryos. So the first thing I would say is that we have, I think, a really strong framework in which to do responsible research. So the only embryos in this context that we can use are embryos that would otherwise be thrown out. So yes, they're destroyed in the process of making the embryonic stem cells, but they were going to be destroyed anyway because the couples who originally had the embryos made in the laboratory were seeking IVF treatment and have decided no longer to continue. That's usually because they have completed their family. And yet they have these embryos frozen and they have to make a decision about where should those embryos go. Around the globe, most countries have a very similar framework. So this kind of heavily regulated, and I think appropriately regulated. This is a sensitive issue, and I think we have to be respectful. But I also think that there's benefit. However, having said all that justification, I do want to say that we don't use as many embryos as we initially did. And partly that's because of this new technology, this new way to make a very similar stem cell in the lab. But it's also because once you make the stem cells from the donated human embryo, you can make lots of them and you can then freeze them and we share them with colleagues where we have permission to do so.
Yeah. And so just to confirm, this isn't, when we're talking about embryonic stem cells, the ones that are being used aren't ones that are purposefully made to be used as for stem cell research and for stem cell treatments.
That's right. And also the correction I think we should talk about, or the misconception we should talk about, is they're not fetal cells. They're not fetal stem cells. So they're not from aborted material. And these kind of two areas are often conflated. There's a lot of confusion. As you mentioned earlier in your description, the embryos that we use in embryonic stem cell research are between 5 and 7 days after fertilization of the egg. So they're in that first week, and they're about 100 cells. They look like a hollow sphere about the size of a dust particle. So there's none of the kind of body plan and perhaps imagery people might think about when they think about fetal stem cell research.
Something in the space that's exciting a little bit of people and researchers is the discovery that stem cells exist in the umbilical cord and placenta of a newborn child. What sort of developments are happening in that space, and what can you tell us about that?
So these are a type of cell that reside in tissue, and they actually reside, they're called MSCs, mesenchymal stromal cells, and they're actually in all of our tissue. It's just that cord blood and placental tissue have a rich supply of them. These are discarded after birth. So there is some residual blood in the cord, and then there's this rich source of placental tissue. So these MSCs have been identified for quite a long time and are in clinical trial. And in fact, the first FDA-approved MSC product has recently been announced, and that's used has been granted permission to be used where people have had a bone marrow transplantation, so a different type of stem cell transplantation to help them with leukemia, for example. But they've developed this nasty condition as a complication from that transplant where the transplant actually attacks their immune system. So it's called graft versus host disease. And there has been a product recently, an MSC product, approved after decades of research for this particular application. And so there's a lot of work and there's a lot of interest, but we don't have many approved products yet using these MSCs. The challenge we face in the field is that because MSCs can be isolated from many types of tissue, including cord blood, placental tissue, and even fat, it's readily accessible. So a lot of clinics are opening up saying, we do this and you can come and have it now. But I strongly advise people to think twice, talk to their doctor, but enroll in a clinical trial. Make sure that the product that's going into you has been appropriately assessed, there's appropriate quality control, that they have done clinical studies to support the use of the cell going into you, and not just kind of carrying on from perhaps the hope and the excitement around the field.
You know, in Australia, this is an area that's regulated by two bodies, essentially. There are strict processes in place to make sure that there is adequate testing and to make sure that these treatments are being done in the right environment. What are the potential harms of a stem cell treatment that might just be wrong for a patient?
So I think the first thing to say is there's the chance it'll do harm to you. And here I'm thinking about cells that are prepared in a lab that doesn't have appropriate quality control. You know, could you get an infection from those cells? I think there's also a question when we're talking about different types of stem cells. You know, these cells grow into other cells. If you don't get the conditions right, could you effectively give the patient a tumour? Because the cells could have this kind of aberrant, uncontrolled, unregulated growth. So again, it comes back to the testing. And in these private practices that are for sort of for-profit, who I think really do want to help people and are genuine in that desire, they haven't yet done the science, and they haven't got people in there saying, hey, where's the, kind of basis for what you're doing? And I think it's left unchallenged. And that's what bothers me, is that there's this kind of lack of rigor and lack of protection for people. So I feel like it's not just sort of putting yourself out there as a guinea pig in terms of accessing something that kind of might work. You don't even know what you're getting. There's no one there checking, like the TGA, checking that the cells are the right kind of cells.
I do want to ask you, we've mentioned a few times clinical trials, and we know of a whole heap that are running in Australia, but I'm curious to know, what are the stem cell treatments currently approved in Australia? Essentially, what's one that I could receive, let's say, tomorrow?
So this is the challenge. There are no approved stem cell-based products in the marketplace. They are still in clinical trial. So with the exception of the FDA-approved, and that was only a couple of weeks ago, so I'm not quite sure whether that's hit the marketplace, it's available. But it's not like you can just dial up a stem cell product at the moment for any of the conditions beyond diseases of the blood and immune system. And I would classify that product I just mentioned that has FDA approval as really treating a challenge of the immune system. So all of the stem cell applications you might think about from the headlines of the last couple of decades, so Parkinson's disease, spinal cord injury, you could probably name it, there would have been a headline about it. We're not there yet. And that includes arthritis. And in fact, there's a clinical trial that has been underway for a couple of years in Australia. It's just finished its recruitment and now in the assessment phase. And I think they enrolled over 300 people. And we're really looking forward to seeing the outcomes from that study to really see whether this product has had an impact on those people's conditions.
Let's pop pause on my chat with Professor Megan to talk clinical trials. Professor James St. John is head of the Clem Jones Centre for Neurobiology and Stem Cell Research at Griffith University, and they recently received just under $7 million from the federal government to develop a world-first spinal cord treatment by transplanting stem cells. Here's Professor James speaking to me about it.
We work on repairing the injured spinal cord, and spinal cord injury is devastating. If you break your neck and break the spinal cord, you lose connection between the brain and the rest of the body below the injury site. And there's no treatment available for that at all. The best doctors can hope for is that they can decompress the injury site and cross their fingers and hope there'll be some natural regeneration. But unfortunately, there isn't. So we're working on a therapy where we can take specialised cells from the nose and then produce them into the supporting cells of the nervous system. And we can then transplant them into the injured spinal cord. We're about to start a clinical trial to test an improved version of this one. It has been tested before by research teams in Australia and around the world and shown to be safe. We just have to make it more effective. Certainly in our preclinical research, it is effective. We need to test it now in humans.
And speaking of your trial, this has been a focus of the government. Last year, they rolled out a $34 million investment package, and you were one of 6 recipients in this space that received that funding. How important has that money been to the work that you're doing?
Oh, it's absolutely critical. We had huge community support for this project, co-designed it, but also we had over $5 million of donations from the public. That helped, and also the Queensland government put in $2 million, and then we put our proposal to the federal government, the Medical Research Future Fund, and they said, yeah, it's a good project to support, and they came in with $6.8 million. So these trials are very expensive. It's costing us over $14 million to run this trial, just because we need to make sure it's all run correctly, reported correctly, and we need to be thinking about the future. This is just the first trial. We need to make sure that we can attract investors to make it, commercialise it into the future. And for that, they want the trial to be run at the highest possible standard. Our aim is to make it successful.
That was Professor James St. John from Griffith University speaking with me there. Before we go, though, let's hop back into my chat with Professor Megan Munsie to find out more about the proven capabilities of stem cells. When talking about stem cell treatments, and especially those offered internationally, there are reports that this is something that athletes really want. This is something that they go to receive stem cell treatments to help with muscle repair and cartilage repair. Is there any evidence that stem cell treatments can actually help in treating certain muscular conditions?
Not convincingly at the moment. So I think there's promise, but we need these late phase clinical studies to really provide the evidence that is required to be able to say, yes, this works for this condition. But what I wanted to mention was you talked about sports stars and professional athletes. It's also celebrities. And that has a really powerful impact on people contemplating. So, if someone's got lots of money and obviously they care for their body, it's an added inducement, I think, and certainly has been used in advertising. So it's something to be wary of, I think, more than perhaps to be excited by.
With all of that being said, would you advise someone travelling abroad to receive stem cell treatments?
I'd certainly ask them to think twice. Sure, do your research, talk to people, find out as much as you can, but take it back to your doctor, take it back to your specialist. They know you the best. They also know the field the best. And they can help you identify where perhaps what's on offer doesn't have evidence to support it and might even waste your time and money and possibly your health that you do have. But I think we've got to be careful about anecdote. Anecdote is not the same as evidence from clinical trial.
Professor Megan, thank you so much for joining us on The Briefing.
I've really enjoyed it. Thank you, Chris.
That was Professor Megan Munsie speaking with me there. Thanks for listening to this special 2-part deep dive of The Briefing. That is it for now. If you haven't caught part 1 yet, hop back into your feed. It'll be there, and it'll also be linked in the description to this episode if you want to click on that for ease. Before you go, though, we'd love it if you could share this app with someone who you think might enjoy it. It's a really easy way you can support us and all that we do here at The Briefing. So we're sharing our social posts. Check us out on Instagram at The Briefing Podcast and on TikTok and YouTube. Just search Listener Newsroom. But until then, I'm Chris Spyrou. Catch you next time.
Listener.